Hello. In this video we're going to be looking at the MANOVA output and specifically we'll go through the data assumption checking. So it's just to remind ourselves why we were doing the MANOVA. So we wanted to explore whether gender had an impact on subjective well-being as a whole. So that's when we consider cognitive, emotional and social well-being together simultaneously to represent kind of subjective well-being. We wanted to see if gender has an impact on that. We also wanted to explore the impact of if you were located in the high non-materialistic aspiration attainment group or a low perceived non-materialistic aspiration attainment group. And then we wanted to look at the interaction between the two to see what was going on. So this is the output that we've produced. So this is just the data assumption checking output and the MANOVA output itself. So I haven't got in here any of the sort of testing that we did to create the median split variable. So one of the first things that we check in terms of the assumptions might be the way that our dependent variables relate to each other. So for MANOVA to work well, you'd like to see that those variables were related to a degree but not too strongly. So we want to avoid any issues with multicollinearity, and they should have a theoretical reason to want to consider them as one kind of thing. So they should be theoretically, conceptually linked to each other. So they should have some level of relationship between them, some level of correlation, but nothing too strong. If they are related too strongly, then MANOVA won't work. Actually, what can happen is it will lose power. It won't detect differences between your groups, or it'll kind of produce nonsense. So it's really important to scrutinise this. So the first thing that we would do to check that is to look at our we had to create an ID variable, and then we had to kind of use that as a dummy variable to run some of the checking that we needed to using the regression function. So the first thing we would want to look at is the correlations, and we're not interested in the correlation with the ID variable, but we are interested in how cognitive well-being relates to social well-being, and we're more interested in the coefficient, the size and the direction of that coefficient rather than the statistical significance. So we're looking here at cognitive well-being and social well-being, and we can see that we have a coefficient of 0.35. And if we go back to the MANOVA slides, we have a table of effect sizes. And actually what we'd want to look at is, well, does that correlation represent a small, medium or large sized effect? So these for R, which is the correlation coefficient, Pearson's correlation coefficient, these are based on Cohen's rough guidelines for small, medium and large sized effects. So we can see that we have a moderate or medium sized effect relationship between those two. So that's okay. We also have a moderate correlation between cognitive and emotional well-being. And between social and emotional well-being, again, we've got a moderate correlation. So that kind of makes sense. We're suggesting that they all fit together as this overall subjective well-being. They do all seem to have a positive relationship with each other, which we would anticipate. They've got moderate correlation, so it's not too strong. We don't have multicollinearity, we don't think. But we'll double check that to make sure that we definitely don't have a problem. And to do that, we'd have to look at the coefficients table that we also produced. And we can see that we have a tolerance and VIF value. So if the VIF value, variance inflation factor value, is greater than 10, we would have a problem. And kind of the inverse of that, if the tolerance value is less than 0.1, we would have a problem and we'd need to deal with that. The problem would be multicollinearity. It would suggest that one of our variables is overlapping too much with the other, or one or both of the other variables. So we'd have to think about kind of either transforming these in some way or stripping them out and looking at them separately, so in separate ANOVAs rather than the MANOVA. That would be another strategy you could use as well. So with this, we could have also produced perhaps our Mahel distances to explore the multivariate normality of the data, to see if we had any multivariate outliers. So we could also do that. That would be, a good thing to look for, and we could use the Mahel distance and the Cook's distance as we would in a regression to see if there are any combinations of factors perhaps on our variables that would be causing a problem. But the next kind of test that we're going to look at then is to do with univariate normality and the way that is traditionally explored. So that's what this next bit of output is around. So if we go to that down here, so we can see from here how many individuals we have in each of our subgroups. So for males in the low non-materialistic attainment group, we have 58. In the high materialistic attainment group, we have 32. And for females, 35 and 53. So we have got a bit of an imbalance here, and our smallest group is 32. Now, Tabachnik and Fiddle argue that if you have at least 20 observation in your smallest cell, then MANOVA should be fairly robust to moderate problems with normality, so that's a good sign. But the flip side is, because we have an unbalanced design, we have to pay particular attention to one of our assumption checks, which is measured using the boxes test. If we have a problem there, then we're going to have to do a lot more digging to see where the problem is and if it's really a genuine issue or if we can ignore it. So that the unbalanced group means it can make your data a lot harder to interpret if you violate some of the other assumptions. So we'll start off looking at normality. So we do exactly as we have done with the ANOVA, and we would look at things like the means and the trimmed means to see how similar they are. We would look at the skew and kurtosis values and pay particular attention to them to see if we have any potential issues. And it would appear probably this group, the high non-materialistic attainment group, on the social well-being variable for males, for example, that is outside those boundaries. So, and we do have a smaller sample size, so this is more concerning. So that could indicate that we have a bit of an issue there, and again, on this variable, on the emotional well-being. And this can sometimes be the issue when you have used a median split, that you're going to get some of these weird-looking skew and kurtosis values. So because we have a smaller sample size, if we do find that we have identified a problem with the test of normality, then it's a little bit more concerning than the ANOVA example. But let's have a look. So some of these look borderline. This indicates there is an issue. For males, the high materialistic group for emotional well-being, and same for females, low and high materialistic, non-materialistic attainment groups. And again on the emotional well-being. So it may be that we have some issues with that we're starting to see here with normality. What we have to decide is whether these are moderate violations or really quite substantial violations, which would mean taking a different approach to the data analysis. So we'll look at the first one, which is the evidence suggests it's not too concerning, and again, it's not perfectly normal, but it's got a roughly normal distribution. There's nothing too concerning there. Okay, this is starting to get less normal, and that one. And if we just scroll through, okay, we can look at our box plots. Again, this looks pretty normally distributed. Nice. The median is in the middle of the box here, and our whiskers are equal length. This one's looking less normal. There's something going on there. These ones aren't too concerning. And again, we're looking at this is much flatter than a normal distribution, but nothing too concerning there. Okay, so we have some outliers, some mild outliers here. So if we have a real concern over the distribution of some of the variables and we find that we have mild outliers, that might be an area where we could either Windsorize those. So that's where you take you replace this extreme score with the next highest non-extreme score. So that's called Windsorizing, or you might want to potentially think about deleting these rows of data and rerunning the analysis and seeing what's going on. So this is it's not looking particularly normal. That's not too bad. That's not too concerning. I'd say we've got so far what we've looked at is mostly moderate violations. And given our sample size, that's not too concerning. We do have an extreme case here. And that is on the high materialistic attainment group for females on the emotional well-being index. Now that might indicate that that's what's pulling that subgroup's distribution out of a normal distribution. So that might be something that we want to explore, either Windsorizing, as we've already mentioned, or removing. So that might be a potential issue. So if we go back to our tests of normality, and we look at the ones that were particularly concerning, that was the potentially, we've got some indications that the emotional well-being, high non-materialistic female group has an issue, and again on the emotional well-being index for males. So it may be that we're going to look at maybe transforming the variables. We'd look back at the skew and ketosis. Yeah, we can see there's some ketosis there, quite significant ketosis. And if we look at the males, again, yes, some considerable kind of skew and ketosis. So we would have to make the decision at this point. Do we think that this is a moderate violation or quite a substantial violation? If you felt it was a substantial violation, you could look at transforming these variables. You could look at potentially the removal of some of the outliers we've identified to see if that improves the situation. Or it may be that you argue that actually we've got to be more radical and kind of break this down and do a series of non-parametric tests in place of this MANOVA. Now that would get more complicated because there's no equivalent to the two-way between groups MANOVA that we're trying to run. You'd have to break it down and look at perhaps a series of one-way non-parametric ANOVAs instead. So in this example, I would be tempted to continue with the MANOVA to look at how it performed on the other assumption checks and so on. But actually what I would first do is to look at so this is the traditional approach to checking normality. What I would do is I would scroll down to where we've looked at the more contemporary approach to see if this sheds any fresh light. So if you remember from the ANOVA output, the reason for doing this is that we look at the residuals and we look at the studentized version of the residual, which is a form of standardized residual, and it helps us to look at all of the cases together rather than trying to split them up and look at different things. And the argument for doing that is that actually each of these residuals takes into account where it is in location to the independent variables, so it's subgroup then. So it is checking normality in the same way that the traditional approach is, but it's doing it in a lot more straightforward way, and we can look at the distribution with more confidence because we are looking at a larger number of cases altogether. So this is the argument for using this approach. We can see that we're looking at all 178 cases together. So in this we can see, because we've got a larger sample size, I would be looking more at the histograms and the descriptive statistics. So the first variable looks absolutely fine. This one's starting to creep towards non-normal, but again, actually within plus or minus 1, and the same for this one. And if we look at the test of normality, okay, the first one's fine. The other two are coming back as statistically significant, so significantly different from a perfect normal distribution. But that could be because of the size of the sample that we have. These are incredibly sensitive when we have larger sample sizes, so over 100 in particular. So looking at the histogram for this one, that looks roughly normal. And again, all of these dots are roughly following that straight line, so that's good. We don't have any really extreme scores. Again, that looks roughly normal, nothing too concerning there. Roughly following the normal distribution. Okay, so in this example, for social well-being, we may have some outliers, but again, they're mild outliers, there's nothing too concerning. And this suggests that actually we've got a moderate violation of the assumption, but nothing too extreme again. So based on this approach, I would use this approach to checking to justify running the MANOVA, because there isn't a non-parametric alternative, because we've got at least 20 observations in the smallest cell, then I'd say that the MANOVA looks like it should be appropriate to perform. So some of the other assumption checks that we have to explore, which are produced as part of the output for MANOVA, and are the boxes test and the Levene's test. We don't have any tests for sphericity in this example because we don't have a repeated measures element as such. So if we look at the boxes test, this is actually quite unusual. Normally you'll find you violate this assumption just as a matter of course, and if you have equal numbers of people in each group, you can just ignore it because it's so sensitive, you can ignore it. In this case, it's more important to check this than ever because we have unequal groups. And what it means is that the smallest group, if that group is associated with the largest variance, then you've got a problem. It will arbitrarily say there's a difference between the means across your groups, when it isn't the means that are different, it's the variance that's different. And so when your smallest group has the largest variance, it becomes sort of dominant, and it influences, it produces spurious significance tests. So if we violate this assumption, we have to, and we've got unequal groups, we have to explore them in more detail. And Tabachnik and Fiddle will talk about how you do that. So Box's test of equality of covariance matrices. Then if we have a look at the significance value, if that is less than 0.001, we have a problem. Now this is well over that, so we can keep going with the analysis and not worry about that, even though we have unequal groups. This is not a problem, so that's a really good sign. The next thing we would want to check are our Levene's tests of equality of error variances, and this is looking at within each specific subgroup on each of the variables, what do the variances look like. So we would look at the means for each of these, and we would be looking for a non-significant result, so which would suggest that the variances are not error variances are not significantly different for each group, which would be a good thing. So if for the cognitive well-being variable we have 0.280, so that's over 0.05, that's a good sign. And then for the social well-being, that's over 0.05, another good sign. And for the emotional well-being, 0.212, another good sign. So we don't have any problems with this assumption either. So we can interpret the significance values in a fairly straightforward way. If we find a statistically significant result, all of these assumption checks suggest it's because there's a difference between the means of those groups. So that's a good sign. So that's the assumption checking done. Have another look through your output, and then move on to the interpreting the results video. So have a go at actually interpreting the results of your MANOVA, but then watch the video to see one way of going about it.